Hello and welcome. Today I want to show a couple exponential equations. Actually, this is a homework help space today. Um, I was asked for some help on this part 61 with these four exponential equations. So let's put our hands to this, okay? All right, so let's go to letter A. It says, okay, behind there, letter A says, yeah, looks good, is e to the x equals to 7. Okay, so we cannot solve that x in there, so we need to apply natural logarithms. So we have the natural logarithm of e to the x, we're going to call ln going forward, um, ln of 7. So we're applying this natural logarithm on both sides of the equation. So by properties, this exponent could come to the front as a product. So x times ln of e equals ln of 7. So this ln of e becomes 1. And this will be x equals to the natural logarithm of 7. So how do we know this ln of e is 1? Remember the property. Let me take another call. The property we have, the logarithm on base a of a is equals to 1. Okay, so the natural logarithm, we know that is a decimal logarithm or a regular logarithm on base e. So if we have the natural logarithm of e, this is actually what? The logarithm on base e of e. When we have this base and this number the same, this becomes 1 by this property. Okay, let's go to the next exercise. It says 3 to copy that letter B. It says 3 to the x plus 2 equals to 7 to the 2x plus 1. Okay, there are a couple ways how we can solve this exercise, but all of those are going to involve applying logarithms at the end. So one of the things that we can do is to remember the property that says that a to the n times a to the m is equals to a to the n plus m. So we're adding the exponents. If we multiply the same base with different exponents or whatever exponent, we will add the exponent. Now, what we need to do is going backward. Okay. Now we have this expression we need to break down. So the first expression in here, 3 elevated to the x plus 2 will be equals to 3 to the x times 3 squared equals to 7 to the 2x times 7 to the 1, which will be just 7. Okay? Remember, we're going backwards right now. We're going from this expression to the multiplication of the bases. Now, we can apply natural logarithm on both sides. And then we'll have ln of 3x times 3 squared equals to ln of 7 to the 2x times 7. Now, another property to remember, the logarithm of AB, the product, is equals to the logarithm of A plus the logarithm of B. Okay? So let's apply this concept to this part. We have the natural logarithm of 3 to the x plus the natural logarithm of 3 squared equals ln 7 to the 2x plus ln of 7. Okay, so what do we have in here? What we can do, when we can try to start doing here, is immediately just try to pass this expression to the left side because we know that is the one that contains x. Okay, Let's subtract minus a natural logarithm of 7 to the 2x and minus natural logarithm of 7 to the 2x. Okay, on both sides, we can do the same in here, minus natural logarithm of 3 squared minus natural logarithm of 3 squared. Okay, what's going to happen in here? So this expression is going to cancel out. This expression is going to cancel out. What do we have? We have natural logarithm of 3 to the x minus natural logarithm of 7 to the 2x equals to the logarithm of 7 minus natural logarithm of 3 to the square. Okay? Now we need to continue working on this. This x, since it's an exponent, could come as a product. X times ln of 3 minus, in this case will be 2x times ln of 7 equals to ln of 7 minus 2 ln of 3. Okay, so what we can find in here, what we can see is that we have a common factor. What is it? Is this x in here. Okay, so let's apply that. Common factor will be ln of 3 minus 2 ln of 7 equals to ln of 7 minus 2 ln of 3. Okay, now let's divide both sides by the same expression here, which is ln of 3 minus 2 ln of 7. Okay, same thing on the left side, ln of 3 minus 2 ln of 7. Okay, this will cancel out, and our result will be only this one in here. X is equals to ln of 7 minus 2 ln of 3 over ln of 3 minus 2 ln of 7. It's not an elegant solution, but I think it's because of the problem. Like there is no, we don't have the same base in here, so it's really difficult to put into an elegant solution. But this is the number. Remember, at the end, this will be a number that if we replace an x in here, we plug in x on both sides, this will become true. Okay, let's go to letter C. Okay, this is interesting. We have c e to the 4x plus 5 e to the 2x minus 24 equals to 0. Okay, what can we do in here? Let's check. On this e to the 4x, we have e to the 2x, so this 2 looks related, right? So let's try to express this e to the 4x as e to the 2x and then elevate it to the square. Okay, this is the same. Remember the property. What does the property says? Remember, a to the n elevated to the m is equals a to the n times m. Okay, we can multiply this exponent. So we'll have plus 5e to the 2x minus 24 equals to 0. Now let's replace. We see that e to the 2x is getting repeated on both terms of the algebraic equation. So let's say e to the 2x is equals to a variable m. I selected m. You can select any variable you want. So here you have m squared plus 5m minus 24 equals to 0. Now this is a quadratic equation, very simple. We can solve by the formula, we can solve by factoring, which I think it's the easy way right now because 8 times 3 is 24 and 8 minus 3 is 5. So let's try. So we have the square root of the first one at the beginning of the parenthesis, then the first sign will come here. The second sign in here will be the product. Positive times negative is negative. And then I need to find two numbers that multiplied becomes 24 and subtracted are 5. That is 8 and 3. Okay. Remember another thing. When you multiply a times b and this is equals to 0, either a is 0 or b is equals to 0. Be really careful with this property. This only works when this is equals to 0. If you have any multiplication equals to a number, it's not going to work. Okay. What else we have? Here, the product of this um, factors is equals to 0, so we can apply this property. Then we'll have m plus 8 equals to 0, or m minus 3 equals to 0. Okay, if we subtract 8 in here, we'll have m equals to negative 8, or m equals, in this case, we need to add 3 and add 3 on both sides. We'll have m equals to 3. But remember, we're not solving for m, we're solving for x. We need to solve for x. Then we need to go back to this expression that we use to replace. Now we know that e to the 2x is equals to negative 8. By definition, this is not possible because e is a positive number, elevated, it's supposed to the square or supposed to 2x, whatever this is, positive, negative, to the, if x is 0, whatever it is, this will never becomes negative. Okay, so there's no answer on this side of the equation. M equals to negative 8 is not a valid solution for our exponential equation. But what about m equals to 3? We have e to the 2x equals to 3. Let's apply natural logarithm. Ln of e to the 2x equals to ln of 3. Okay, the 2x will come down. Ln of e equals to ln of 3. We saw on the previous exercise that ln of e becomes 1. So we'll have 1 times 2x, that is 2x equals to ln of 3. Divide by 2 on both sides, and x is equals to ln of 3 divided by 2. All right, that is the exercise of letter C. Okay, now let's work on the last one. Let me see. This is letter D. Let me pull this up a little bit. There we go. Okay, letter D says 4 to the 2x minus 1 equals to 64. Okay, this is a very simple exercise. I mean, maybe it doesn't look like, but it's very, very simple. Let's remember that when we have a to the n equals to a to the m, okay, if the bases are the same, we need to make the exponents to be the same as well. Okay, so then we have n equals to m. So we need to find a way how to manipulate this 64 to create the same base. Okay, so we have 4 to the 2x minus 1, and we know that 4 times 4 is 16, and 16 times 4 is 64. So this 64 can be expressed as 4 to the cube. Now that we have the same base, we're going to solve the equation of the exponents to be the same. So we have 2x minus 1 equals to 3, and we just need to solve this one. Adding 1 on both sides, it's gone, and we'll have 2x equals to 4 divided by 2 on both sides, and then we have x equals to 2. That should be my answer. Just a very simple and quick verification. If we plug this 2 on the initial equation, 2 times 2 is 4, minus 1 is 3, and then I have 4 to the cube equals to 64, which is correct. All right, thank you so much for watching. Thank you for sending these exercises. We're more than happy to help our students. Remember, um, we're gonna go live with a couple more things to solve. You can send your assignments, exercises that you need some help. This is where you can send it. Is go mrmath.com. Okay, thank you for watching.